Hey, welcome back. Today we're going to talk about sampling distributions for the difference of means. And when we do that, we're going to look at, a particular problem. We find some of the characteristics of that sampling distribution. So let's go ahead and get started. What we're really looking at is kind of throwing this back to the very beginning of the year when we started to talk about center, shape, and spread. And we've got some measurements for that as it applies to the sampling distribution for a difference of means. So here's what it looks like. So we are looking at the shape, center, and spread for the sampling distribution and I'm going to abbreviate that dist of, now if we're talking difference of means, that's x bar 1 minus x bar 2. Okay, so when we're talking about shape, what are we looking for? Well, obviously, like we've been talking about for a while now, we want to have that normality, and there are a couple ways that we can assess for normality. And so shape, what we need to take into account is that we're actually dealing with two samples, right? So we're dealing with x bar 1 and x bar 2 that come from the populations x1 and x2. And so when we look at the shape, we are assessing normality together. So both of them must meet these conditions. So both samples meet these criteria. They've got to be normal. And they don't have to be normal by the same criteria, meaning x1, so population 1 and population 2, or sample 1 and sample 2 don't have to come from populations that meet the same criteria for normal, right? One can be approximately normal, one could be essential limit theorem, one could show no shape or skew. So you can mix and match here, but they have to meet one of these three. So first of all, the population, it could be normal. Or your n could be greater than or equal to 30, and we could use the central limit theorem. Remember, n greater than 30, we're talking about means here, so the central limit theorem can be applied. Or we could have no strong skew or outliers. Okay, no strong skew or outliers. Our center is going to be the measurement that we're looking for, and that's going to be the difference of our mu's here. 1 minus mean x bar 2 is equal to okay, and then our spread, we've got a formula here. Spread. So we have our standard deviation formula here. Standard deviation of x bar 1 minus standard deviation of x bar 2 is equal to big under the square root, kind of like we've become accustomed to, right? So standard deviation 1 squared over n1 plus standard deviation 2 squared over n2. And that formula can be found on your formula sheet. That's one of those ones that we can find there. So that's the basic gist of it. This should look very familiar to you, right? So we're assessing normality, so checking those normal conditions. Then we're going to find the center by taking the difference in the means, and then we're going to find our spread by finding the standard deviation for a population, for two samples for difference in means here. Let's look at an example. The heights of young men follow a normal distribution, so kind of right there, with a mean of mu sub m is equal to 69.3 inches and a standard deviation sub m is equal to 2.8. The heights of young women follow a normal distribution. So again, there's our kind of keywords there. And they give us the mean of 64.5 and a standard deviation of 2.5 inches. Suppose we select an independent, simple random sample, that's important, of 16 young men and 9 young women to calculate the sample mean height, x sub m, and x bar sub w. So x bar sub m and x bar sub w. What's the shape of the sampling distribution? So like I outlined here, we've got a normal distribution for men and normal distribution of women. Now, one of the things about watching this video is you may want to pause here and work through A, B, and C together, work through A, B, and C on your own, and then come back and unpause it, and I can show you what I got for my answer, so that can be a way to check yourself so you don't get lulled into a false sense of, oh, I know what I'm doing, because he knows what he's doing, okay? So the shape of the sampling distribution should be approximately normal, and why? Well, both distributions the distribution for men and women are normal. So because both of them are normal, we can assume the shape of the sampling distribution for the difference in those means is going to be normal. Let's find the mean. Well, our mean x bar sub m minus x bar sub w is equal to the difference in the means, which is equal to 69.3 minus 64.5, which is equal to 4.8. So our sampling distribution, the mean of the sample distribution should be 4.8. Calculate and interpret the standard deviation. So bar sub 1 minus the standard deviation of x bar sub 2. Really, this is just, we put different subscripts on it, right? But this is the same this is the same exact process for finding the difference in two standard deviations. So when I write out my formula here, I've got squared over n1 plus squared over n2. And then I'm going to plug and chug, put in my numbers. Standard deviation of my x bar sub m is going to be 2.8. So I'll square that and put it over my number of men in my sample, which is 16. And my standard deviation for my female population is 2.5. Square that, put that over 9, because that's the number of women. And then when you do the math there, and this is where you could pause and try to see if you can, if you're getting it right, we get 1.088. What is the interpretation of standard deviation? We've been working on this for quite some time now, and so even in this new context, still the same. The difference in means typically varies from the mean difference in means, which is 4.8 by 1.088. And you can put a little context on this, right? So the difference in means for heights men minus women. So the difference in heights, the difference for heights, men minus women, in means, typically the difference in mean, I should put that here. The difference in means for heights of men minus women typically varies from the mean difference in means of 4.8 by 1.088. And that's all there is to it. This process, like I said, should look familiar. If it's brand new to you or if it's looking unfamiliar, hopefully that gave you a gist of how to find those difference in means and how to operate to find center, shape, and spread. But thanks for watching, and we'll see you next time.